Alright, I have just generated some practice questions for the Module 8 quiz. Let's go ahead and see if they make any sense. And also, while we're doing this, I'm going to show you some tools that I would be using if I was in your position. Besides Excel, which we've spent a little bit of time on, and I think some of you guys have picked up pretty well in the past few modules, which has been nice to see. So, our first couple questions are pretty simple, just exponent rules. So if I was going to be doing a timed quiz and I knew that this was going to be on it, I'd want a cheat sheet where I just kind of put down some rules to help me think through this. Failing that, what I always do is just kind of generate some really simple examples in my head just to test, just to make sure I'm remembering things correctly. So for example, y to the power of a to the power of b, am I supposed to add a and b? Do I multiply them? What's going on there? If I imagined y is going to be 2, right? Just a nice small number. And let's say a is 2 and b is 3, well then I can think my way through this. I'm going to go ahead and actually use r for this. Just to do the calculations. So if I have 2 to the power of 2, that's going to be 4. 2 times 2. If I have 2 to the power of 3, that's 8. 2 times 2 times 2. If I have 2 to the power of 2 to the power of 3, 64. So that's 4 times 4 times 4. 4 times 4 times 4. All right. So let's try 2 to the 5. That's not it. 2 to the 6 is 64. All right, so 2 to the 2 to the 3, I want to do 2 times 3. That is simple enough math that you could, in a pinch, do that in your head, maybe with a piece of paper so you don't have to remember too much stuff at once, save your working memory for the test itself. But for example, when I was doing the GREs a million years ago, there's a lot of exponent math on that. So if you're thinking going to grad school, being able to kind of parse your way through that pretty quickly when you don't have access to a cheat sheet is useful for that. So what have we got? Y to the a to the b. That is going to be y to the a times b. Let me see. Let me get a... What do I want? Let's just get a text editor. All right, so question 1, y to the a times b. Let me make this bigger. References. Oh, here we go, fonts. All right, now we'll be able to see that. All right, question 1, y to the a times b. All right, now we're looking at question 2, z to the 9 times z to the minus 4. All right, this is also, I think, going to be a little easier to do with R. If you know another programming language, same basic things are going to apply. In most programming languages, this little caret, shift 6, means an exponent. One exception would be Python, where we would do double asterisk to show an exponent. But this isn't Python, this is R. So we want z to the 9 times z to the minus 4. So here, we just multiplied a times b. Here, I think we're going to do z a plus b, right? Which means in this case, z to the power of 9 minus 4, z to the power of 5. So let's go ahead and test that out. So let's say z is going to equal 10. Actually, can we do that? 10 to the power of 9? That's a big number. Okay, it's just 9 zeros. Okay, that's easy. So if we do z to the power of 9 times z to the power of minus 4, we're getting 1 followed by 5 zeros. right? So that checks out exactly with what we had. Let's just try a different number for z. Z is going to be 5. We rerun this. We're going to get a different number. But let's go ahead and just check each part of that. Z to the 9 is that. Z to the minus 4 is a small fraction of that. So we're just getting this small fraction of that, turns into that, passes the smell test for me. I don't know my 5 exponents, but 10 exponents, that's nice and easy. Back to that little hint earlier about using these sort of simple numbers to parse through the exponent rules. 10 can be a useful number for this. I think 0, 1, 2, 3, 10, those sorts of numbers can be useful, but there's sort of an art to what works specifically. You get that with practice. All right, so we've got our first 2 questions. Now we're getting into the harder part, the word questions. So we've got a furniture company producing chairs and tables. So we're looking at a production constraint between 2 things. We're going to have a 2-dimensional graph like a PPF. We have a fixed amount of workspace. We've got a budget for materials. Each thing is going to require a certain amount of space, a certain amount of materials, a certain amount of time, and we're going to have some labor going into this. Set up a system of inequalities that describe the production constraints. Use C for the number of chairs and T for the number of tables. All right, so here's what I'm going to do here. I'm setting myself up to use an LLM to help me figure this out. I want to try and put myself in your position. So before I parse this question and try and make sense of it, I'm going to assume that it doesn't make any sense to me at all. So I'm just asking Claude, I'm about to start some practice questions for a math quiz. I don't know where to start. Here's the first question. Let's see what it gives me back. All right, so it's going to set up a step-by-step approach. We'll consider each constraint separately. So we got the workspace, the budget. We've got non-negativity constraints. Cool. All right, so that makes sense. So we've got limited amount of space. We've got information about the chairs. Each chair requires 4 square feet. Each table requires 9 square feet. All right, so that's just straight out of the question. We've got our total workspace, and so we can illustrate if it's going to be, we're not stacking our work or anything like that. We're just using 4 square feet for each chair, and we're not worried about like being able to move through this. We're abstracting away from the feng shui of our workshop. Then we are capturing how much space can we use? Well, if we do a bunch of tables, then we have to divide 300 by 9. Right? Let me go ahead and show you the other tool that I would use here, which is Wolfram Alpha, which you can get to at wolframalpha.com. And let's just have this graph this inequality. Cool. So if we used all of our space for chairs, we could do a larger number of chairs. If we use all our space for tables, we're going to have 300 divided by 9. So let's just round this and say it was 10. If it's 10 square foot per table, we could do 30 tables. We can do a little bit more than that because it doesn't take that full 10, so that looks about right. 300 divided by 4, that would be 25. Let me think this through. So I'm doing mental math here. So if we had 100 square feet and it took 4 square foot per chair, we could do 25 square foot. So this should be, 25 chairs in 100 square foot. So we should do 75. This doesn't look quite right. 300 divided by 4 would be 3 times 100 divided by 4, which would be 3 times 25. 75. Am I? All right. I'm not going to worry about the specifics right now. I'm sure I'm missing something simple, but we've got a plot. Right? We've got a representation. So given the space, these are our possibilities, right? So we could do, oh, wait, that looks weird. let's add something. So part of why this looks weird is that 0, 0 is up here. It's saying, what if we had negative? Okay, that's what I'm missing. This is why we do the smell test. So if I look at this, it goes way down to here, but this is at a value of, I think, negative 20. So let's add a constraint here. C has to be greater than or equal to 0, and T has to be greater than or equal to 0. Wolfram Alpha is usually pretty good at figuring out what you want it to do. Not today, though. Let's try a semicolon. Okay, that looks better. Okay, yes, so 75. Cool. All right, I'm back on board with this. So let's take a look at what Claude is telling us. So there we've illustrated our workspace constraint. We've got the inequality describing this. This is just like an equation, except with a less than or equal instead of just equal. If we're saying just equal, if we were going to use 100% of our space, then we'd be looking at any combination along this line. We could do 75 chairs, we could do 32 tables, we could do 16 tables and 40 chairs, or whatever, right? With the inequality, we could also do 10 tables and 20 chairs, right? That is within the capacity. We could do 0 and 0. That is within our capacity. All right, then the budget constraints. Here we've got more moving parts, so it's going to get a little trickier. I just put in the non-negativity constraints, right? We can't have negative chairs. So that is captured in here. So our semicolons did the trick for separating each of the parts we want to incorporate into this plot. We want to graph this inequality, but we want to make sure C is greater than 0, T is greater or equal to 0. That's captured in here. So we've got budget constraints. Materials cost this stuff, right? So each chair costs a certain amount. So given a $5,000 budget, we can only make up to 50 tables, right? Plus we need to think about the cost of the labor. So if it's going to cost $100 in materials plus $20 in labor, it's costing $120, right? Cost per table, $120, cost per chair, $60. The labor there is a little bit of a red herring. It's kind of an unnecessary wrinkle. But that's fine. That happens in life. Sometimes we have two different categories we can just lump together. In this case, we just lump it together into, it's going to be this much cost per chair. So our total budget is $5,000. We've got $60 per chair. So if we made just chairs, we'd have to divide 5,000 by 60, and that's the number of chairs we could make. If we made just tables, we divide by 120, and that would give us our maximum possible value for T if C had a value of 0. So let's go ahead and take this, drop that into here with another semicolon. And what's happened? Not much. Let's see what happens when we get rid of this. Whatever. I'll check on that in just a sec. Okay, so we go to a maximum, interval notations. What have we got? Interval solutions. Solutions, yada, yada, yada. Okay, so we've got a maximum value for C of 250 over 3 compared to T being 1/6 of 250 minus 3C. We're not going to worry about what exactly that means, but I believe these are the endpoints, if I'm reading this correctly. So we go back to where we had this. Let's get rid of that part. Is it going to give us solutions? No? Whatever. All right, so we go up to, let's say, 32 and 75, and then when we go here, and we're looking at our budget constraint, not our space constraint, this goes a little bit higher. So it wasn't quite 32, and then this gets a little bit more, right? This was kind of 80-ish compared to 75-ish. So this is just the budget constraint. Let's go back to the budget plus the space constraint. Notice we have a lower capacity for tables and we have a lower capacity for chairs. So what does that mean? Can we plot both of these on one? See if I can just tell it to be green and red. No. Closest interpretations, no. Use it as a variable. Okay, that's what it meant about using it as a unit. Huh. Okay, so sometimes you throw a bunch of stuff into Wolfram Alpha, and there's a lot of parsing involved. So, trying to force it to give us particular colors didn't do the trick. Natural language, no, whatever. All right, so long story short, let's do this. MS Paint, basically what's going on is we've got our graph. Let's make this a little easier to see. Come on. There we go. That looks better. I take it back. Let's try it like this. All right, we're in dark mode, so it's not showing up. Okay. So we've got chairs and tables, just like we did before. Okay, whatever. Chairs and tables. What we just got was our space constraint was here, and then our budget constraint was out here. When we put that together and ask what is our actual constraint, when we put both of these things together, basically what we found is that the binding constraint is the space. I might be flipping these backwards and forwards, but whatever the smaller one is, that's our binding constraint. So we have more budget than we're able to use in this case. What does that mean practically? This means save up your money and move into a bigger space to increase your capacity. It means that what we're short on is space and not budget. All right, so coming back to here, and actually let's just note this URL, paint.js.org was very useful for this. So in this quiz, you're going to have to do a graphing question, and you're going to have to upload a graph. In the quiz itself, it's not going to be too bad, but there is going to be the show your work. If you aren't able to figure out how to upload it into the quiz, then just include it and show your work and you'll be fine. So you could, for something like this, go File, Save As, and it'll download this. You can rename it and upload, or don't even bother renaming it. It'll be fine. All right, let's go back to our questions. So we got a furniture company producing chairs and table. We've got these constraints. Set up a system of inequalities that describe these production constraints. Use C for chairs and T for tables. All right, so Claude really did our hard work in this case. So taking a step back, what we should be doing in a case like this, what matters is understanding. And that's really kind of how we're able to try and get something out of this, and how we're able to convert that into a graph that's useful. This is not a great way to have Claude help you do a practice question. So let's try this again. Let's make a prompt to kind of be more like a tutor. I want you to avoid giving me the answers. please help me plan my approach to the next question and ask helpful questions like a good tutor would, but leave it to me to actually solve it. Please outline a plan I can follow to solve this problem. Let's go ahead and grab our next practice question. Dolls and action figures. All right. It's been 20 minutes. Thank you for being patient. But we have seen a lot of useful tools already. We've played around with R a little bit, which is really just serving as a calculator. A calculator would do the same basic task for you. But that's helpful for figuring out the rules of exponents in a pinch. Now we're getting a little use out of an LLM. I know ChatGPT is the more popular one. I use Claude for whatever random reason. I just started using this this semester, and I've been happy with the interface, so I've been sticking with it. And here we've seen a bad way to use it, which is just give me the answer. And it did give us the answer. We can double check its math. Actually, no, the math checks out. This was nice and simple, right? $60 per chair, $120 per table, $5,000 budget total. All right, so we're doing fine here. But to get better practice out of this, we don't want to just give us the answer, because that tricks us into thinking that we understand something that we don't, which means that we're going to be vulnerable when it comes up on a quiz and there's some sort of a twist in the question that ChatGPT doesn't handle well. In this case, it was a simple enough practice question that it didn't bite us in the ass, but let's be careful. All right, so we got this situation. Identify the variables. What do D and A represent in this problem? Dolls and action figures. Resources and their limits. Our two main resources, we've got plastic and we've got labor. And now we've got a limited amount of labor, right? So in our first question, we could just buy as much labor as we wanted. I guess we could go out and pick up as many day laborers as are hanging out in front of the Home Depot on any given day. In this case, we've got employees and they're showing up, and we've got access to 500 of their hours, and that's our fixed amount. So we've got time, we've got plastic. We've got a limited amount of both, and we've got to split that between dolls and action figures. So we're going to have something very similar, right? So we're going to ask how much plastic per doll, how much plastic per action figure, how much plastic in total. How many hours per doll, how many hours per action figure, how many hours in total. So let's go ahead and start. For plastic, we've got 2 pounds, so we've got 2D plus 1A is less than or equal to 800 for a resource constraint. And for time constraints, we've got 1 hour of labor and then 1.5 hour of labor. So 1D plus 1.5A is less than or equal to 500. So our question, set up a system of inequalities that describe these production constraints. Use D for dolls, A for action figures. List the resources and their limits. We've figured out the basics for each product. How much resource does each use? Set up the plastic constraint. We've done that. Set up the labor constraint. We've done that. Consider non-negativity. D is greater than or equal to 0. A is greater than or equal to 0. Combine all constraints. Let's just plug it in and see how the LLM responds to us. Let's review it step by step. Sure, everything is correct. Now, don't trust LLMs with math. They are good at putting words together. In a year or two, maybe they'll be good at math, but don't trust them yet. But let's go ahead and look through. So we said 2D plus 1A less than 800. Does this accurately represent the plastic usage for both dolls and action figures? Yeah, so if we do just dolls, then we've got 400 dolls we could make. Just action figures, 800 we could make. If we did half and half, if we did, say, 200 dolls and 400 action figures, that would also fit. All right. Does this represent the plastic usage? I feel good about this. I feel good about the labor constraint. It's been 25 minutes, so I'm not going to go through specifically, but pause and make sure that this fits in your head, just to be safe. Please print out those constraints in a way that Wolfram Alpha will be able to generate a visualization of them. Let's see how good Claude does on this. So this is the other big tool we're using, and in this case, it's going to be useful for drawing the picture. We could get away with using paint. You know, we don't have to be super accurate here. It doesn't have to be to scale. This gets the big picture across. Let's go ahead and see if this does this. Copy, paste. So our other big tool, Wolfram Alpha, this is going to be more useful when we get into calculus stuff. But, hey, there we go. So here's a slightly different shape than what we saw last time. So now when we put these constraints together, this line would be going past here. I think this is our plastic constraint. But given our labor requirements for whichever good this was, we just don't have enough labor to use all of the plastic on this particular product. So the result is we get this kink in our constraint, right? In what we could do. When we put these two constraints together, they intersect. So on this corner, we don't have enough labor, I believe, and then in this corner, we don't have enough plastic to use all the labor that we could have had. Cool. So in that case, basically what we would expect, I'm going to do a slightly messy version of this, is we might have the one constraint looks like this, and then the other constraint looking like this. And so what is actually available to us, where's our fill bucket, is this area here. Right? So that's what we got out of Wolfram Alpha. Now in this case, we got a decent thing here, and we could just go take a screenshot, grab this, copy it into our work, or download it to upload into the quiz. That's a nice, easy way to get a nice, accurate graph. And to show your work, if you just grab this URL, this will work. So I can click this into a new tab, and it will show me exactly what you were looking at. So when you show your work, this kind of lets me see, did you make a mistake? Was there some little tiny error, or were you getting everything exactly right? Or did you just plug nonsense in and just play around with it? And of course, you're allowed to do that. But give me a URL or a set of URLs in your show your work if you're using Wolfram Alpha. Of course, here, just the image does the trick. And then, of course, also if you're using an LLM, this is also part of showing your work. So I say no holds barred when I'm talking about these quizzes, and I mean it literally. So here, I don't like this, but I did use a tool and it gave me the right answer. Double check it, right? Don't trust the output of the LLM, but we did kind of literally get this. I'm not going to ban this because I don't have a way to enforce that. But what I will require is that if you're going to do something like this, I want you to share your work. So you might, print to PDF. That doesn't capture all of it, but whatever. Save it into a Word doc and upload that. Just copy paste the whole thing. Show me how you got this. Even if the LLM did the hard work for you, I want to see that you were bossing the LLM around, right? That was your work. You were playing manager in that case. Like I said, don't trust it, but if you did in this case, that is part of showing your work as well. All right, so back to our practice questions. Our last one, I believe we are going to set up our system of inequalities, describe these production constraints, then draw a graph use C for the number of cakes, P for the number of pies. So now we've got a constraint for flour and sugar and oven time. Each cake requires this. Okay, so things are getting a little bit more elaborate. So, cakes and pies, these are our axes in the right direction here. You know, we make more cakes, we make more pies, and we're going to have some sort of a constraint between these. Oh, you know what? I wonder if Wolfram problem generator. I feel like Wolfram has talked a little bit about LLMs. I think there might be a Wolfram GPT also. I'm just going to come back to this in the future. All right, so we've got our final question here. We've got this constraint in terms of flour and sugar. Let's go ahead and so I'm going to ask it to give me the answer. Oh, come on. And then capacity constraints, of course. So I'm asking, give me, let's say, a version of the answer to this next question with 2 errors, and I'll pick them out. So here's our question. Let's try sending this and see what it gives us back. Okay, provide an answer, version of the answer with the next 2 questions, yada, yada, yada. Bakery produces, blah, blah, blah. We got this. Oh, we ran out of responses again. Can I change the model? Not without going into a new thing. All right, so I'm not going to bother going through the specifics here, but we're going to have a very similar sort of a thing, except now we have to say our number of cakes. We're going to have a set of constraints for the flour, 2 pounds of flour times cakes plus 1.5 pounds of flour times pies, 1.5 pounds of sugar times cakes plus 1 pound of sugar times pies, a certain amount of oven time for cakes and pies. So we're going to have an inequality for flour, an inequality for sugar, and an inequality for oven time. We're going to put those all together, and maybe they're going to intersect like we had in that previous one, but we're going to get the same basic sort of an outcome. And then again, we're going to copy paste that visualization into the quiz itself. All right, so let me sum up because it's been half an hour. We've seen some tools that we can use to help us with this stuff, although we've also seen that they're kind of unreliable. So if you're doing your quizzes at the last minute, using an LLM might not be a great idea because it might not work for you. But it is a helpful coach, and it can help you to practice with this if you ask it to do the right sort of thing. Right? So if you just say, here's a question, and it gives you the answer, that's not going to help you practice. At that point, you might say, give me a new version of this question and don't give me the answers. So LLMs can be useful. Wolfram Alpha is going to be a lot more useful in the near future, but we can also see that it was useful for drawing these inequalities also. Or you could do a hackier version in Paint or whatever drawing program you like. Cool. Right, I like these questions. These questions actually might be a little bit better than the questions in the quiz, but you'll be fine. If you can get through these questions, you'll have no problem on the quiz. Just take your time, keep your scratch paper. Yeah, all right, cool. I'm going to stop there and let you get to it. Hopefully this was helpful. If you just copy these questions into your LLM of choice and say, give me some more practice questions like this, it'll give you some more questions, and you can, figure out those answers on your own. practice makes progress. It's good for you. It gets this stuff into your brain a lot better than watching me do it and then hoping for the best. All right, so if you have any questions, let me know in the usual places, and I will talk to you in the future.